Hello, and welcome to Advances and Emergent Needs in Paleogeoscience and Cyber Infrastructure. This is a webinar series organized by C4P. C4P is the Collaboration in Cyber Infrastructure for Paleogeosciences. It's an EarthCube research coordination network supported by the National Science Foundation. I'm Jack Williams, and I'll be the moderator for today. Leslie Sue will be running the WebEx, and we'll be monitoring the chat window and questions that come in that way. In today's seminar, we have two presentations, each 20 minutes with roughly 10 minutes afterwards for questions. We want to keep this to an hour, so I'll be fairly strict about enforcing time limits, and we'll give each speaker a 3-minute warning before the end of their 20-minute window. If anybody listening has questions during or after the presentation, please send them through the WebEx chat window, and Leslie will read them aloud after the presentation. And as a related request, please have your mics muted so that we can have minimal sound disruption to Ilya and Eric's presentation. You may send in a question at any time by the chat window. All the presentations and the follow-up discussion will be publicly archived on the EarthCube website. Our first speaker today is Dr. Ilya Zaslavsky of the San Diego Supercomputer Center, who will be speaking about the community inventory of EarthCube resources for geoscience interoperability, known as CINERGI. And our second speaker today will be Dr. Eric Grimm of the Illinois State Museum, who will be speaking about the Neotoma Paleoecology Database. We'll begin with Dr. Zaslavsky. Welcome, Dr. Zaslavsky, and you may begin when ready.
Thank you very much, Jack. Shall I start? Can you hear me okay?
Yes.
Okay. So I will talk about EarthCube building block project called CINERGI, or Community Inventory of EarthCube Resources for Geoscience Interoperability. And the project derives from several needs that have been expressed by the large geoscience community. One is probably something that is most often mentioned is that data discovery is needed across multiple geoscience domains, and that has been mentioned in most of the executive summaries of EarthCube and user workshops that we've seen. There's no one place where one would go to find out what is available in terms of data, models, and tools, but especially data. And in part, it's because the situation is very dynamic, available data volumes grow rapidly, and techniques become more sophisticated, so it becomes ever more important to be able to find what you need and evaluate whether it fits your expectations. Another common sentiment is that one of the modes of failure for EarthCube would be if people don't know what is available. As a result, there would be duplication of effort, waste of resources, and generally much more fractured community. So the goal of CINERGI is to help with this by creating a high-quality resource that will compile and present metadata about data sets and other types of resources across multiple geoscience disciplines. And this is what I'm going to talk about today. The first question is what we're trying to inventory and why, and then we'll get to how. So I'll start with a picture that I have shown a few times already. This is from our earlier roadmap project, and an attempt to describe how we see EarthCube at a conceptual level. Here is the central tier, the geoscience communities and the main information systems. Imagine that you are researchers, say, in hydrology, and you are trying to access geochemical data. You would want to be able to discover this data, interpret what you found, access the data, and then integrate it with other data that you have. So that would translate into the need for having catalogs that will support discovery needs, vocabularies, services, and other data access mechanisms, and information models that will describe what are the elements and structure of the data that we're getting. So what we try to do initially is to see what we can get in terms of vocabulary, services, information models, catalogs from multiple domains in EarthCube. One issue is that all of these components may be represented in a number of different ways. When we talk about vocabularies, there are several ways of representing this data as scores, as OWL, as taxonomies, as simple lists, and that makes it fairly difficult to create interoperable systems. Same applies to catalogs and services. So this is where EarthCube is trying to do, and actually the domain of EarthCube is this upper layer, as I understand, where we try to develop systems that will help with cross-domain integration, meaning that will have vocabulary crosswalks, federated catalogs, synthetic data sets that are composed from compatible services. Another issue is that lots of data are a lot more data are collected by research sites and do not end up in the domain systems. How we discover this data, access this data, catalog them is a fairly difficult problem that is not solved yet, but we're trying to propose some solutions within the project. So this is where we started in the previous project, and it's one of the outcomes where we try to create an inventory of high-level resources that describe vocabulary services and information models. You can try to go to connections.earthcube.org website and see it by yourself. I'll show you a glimpse of the user interface, so you can look at what is available. For example, I'm looking at information model services and other things by different domains. Say you're looking what is available in terms of climate trackers and also climatology, elevation models, and so on. You can try to experiment with that yourself, but the idea is that there's a very simple entry point to see what is available in terms of high-level resources. That's another picture of the same. You can zoom into resources and get more information. And so far, the focus has been on the high-level descriptions, what exists at the level of domains, what catalogs the domain is using, what services, and so on. But the goal of CINERGI is also to catalog data sets and other types of resources and create a large inventory of high-quality metadata with traceable provenance that can be used across multiple research scenarios, make it open to the community. Even in the example that I showed before with this catalog, there's an entry point to it where you can edit and suggest additional resources, because certainly we do not yet have a complete inventory of high-level resources in CINERGI. It is open to the community for people from different domains to add what they use and what they know about. And the next goal is to organize it such that we can do search not only for data, but also we can navigate between different types of resources, getting from data to users who have and authors of the data, to models where these data have been used, publications that reference the data, and so on. There are a number of unresolved questions. How we scope and prioritize CINERGI work, given that there are indeed many different types of resources used by geoscientists. A very big issue is different levels of granularity that we deal with. Some catalogs deal with data sets. This is the most common. Other index what they call collections, biological collections in particular. Other deal with samples, and there's an excellent geochemical data system work done at AIDA, for example, that deals with sample descriptions and also includes physical samples. Others catalog time series, such as hydrologic time series. How we develop search over catalogs of different levels of granularity is not quite clear. Lack of formal information model is a big obstacle because quite often putting together data, researchers do not quite document all the fields and all the fields that would be useful when we try to connect this data with other types of data. Domain semantics may be implicit. There are multiple metadata registry platforms that we need to harvest. GeoPortal that can use CSW and web accessible folders and a few other mechanisms to harvest data from others, but there are also Mercury, CCAN, and a few other platforms. As I mentioned, there are lots of data outside managed repositories, and it's generally not yet clear how a cross-domain search and cross-domain resources will interact with domain systems, because there are many domain systems, as I mentioned, shown at this earlier picture. Each of them, or many of them, have their own search mechanisms. If you provide inventory and search over a cross-domain system, how will the communication happen between search systems and individual domains undoubtedly? Not to mention that if we're trying to build a cross-domain search engine, then we have to deal with different expectations and different patterns of geoscience domains. Another application that you can find on connection to the EarthCube.org website is a survey where you can look, for example, at, I will enter Paleo, and that will give me all respondents to the EarthCube survey who mentioned that they who had the word paleo in descriptions in any of the answers to their questions. And we can see that for this group, it is fairly important to use, critically important for most, to use data sets from other domains. It is also not easy. Most of the people said that it becomes a real problem to access data sets coming from other fields. And also there are other interesting things of how you can try to use the survey to characterize the community. For example, how often this group deals with, say, atmospheric science people. Most of them say never. But geologists are certainly the favorite group of people that Paleo folks work with. Moving on. Yes, so the approach we follow in CINERGI is trying to build on the initial high-level inventory, but also compile metadata by from many different catalogs that are available from domain information systems. Expose them through simple search interface. We're currently using GeoPortal, and make this all available through the EarthCube website. This is a glimpse into how it is organized internally, at least the harvesting process. So we harvest resource description from catalogs that expose CSW or AIMPH or similar type of interface, and put this into a staging database where we analyze what we have harvested and whether there are deficiencies in the metadata, and fill in fill in gaps and checking for consistency. Then pushing this into public inventory that can be searched by searched online. This is a much more detailed and much uglier view of the system. The first stage, harvesting, is when we, as I said, harvest data from several via several interfaces into a staging database that will be. We're currently working on MongoDB implementation of it. Once the data without validation is is deposited here, then we can check metadata and see if there are any issues with that, and then trigger different types of parsers. For example, if a spatial extent is missing, then that would involve a spatial parser that will fill out that field. If there are some inconsistencies in attribution of the records, then there will be a person parser. Missing keywords, missing or incorrectly specified topic. So there will be a series of parsers with a parser API that will make the metadata more consistent. Then another issue is that it happens quite often that we get similar metadata records pointing to the same resources from multiple repositories, so duplicate detection is an important piece of it. Staging database exports XML ISO descriptions, and then these are imported into GeoPortal, and also all other information, including provenance, links to other types of resources, annotations, and extra metadata that is domain specific, goes into an RDF store and exposed via exposed via GeoPortal search UI, and then it is the search results are also exposed via pivots, the same system that I showed for surveys. So once the basic system is built, then we add links to organizations, researchers, other types of systems, add validation services, and also do deep registration. Deep registration not at the level of data sets, but at the level of features such as samples, time series, and so on. So we have two set of queries that we want to satisfy. The tier 1 set of queries would be basically addressed with the basic system that harvests dataset metadata, the one that I showed on the previous slides, on the previous diagram. Then you should be able to find resources given a theme, a geographic area, do query expansion. So essentially what is supported by standard CSW ISO type interfaces. And then we will add linked resources so that you should be able to navigate from data sets to the types of specification that these data sets subscribe to, types of services that it can be accessed with, and authors, annotations, and so on. Something is already in place, so we started with the GeoPortal, as I said. It has about 28,000 records at the moment, mostly as a way for us to experiment and train the parsers. And we also have a resource at metadata.earthcube.org that where we ask community folks to suggest what resources need to be harvested.
17 minutes, 3 minutes left.
Yeah, what resources need to be harvested into CINERGI. This is how the system works. When you ask for a data set, when you would like to suggest a data set, it may already reside in some repository, and there's a list of repositories here. In that case, we would just harvest that catalog eventually. If it's not in a repository, we can try to connect you with the appropriate long-term place where the data may reside. We started working with the C4P group with Doug and Anders. So there is actually a first version of pivots that is now available that shows resources collected by these communities with several domain user workshops, and eventually it will be made public and so that C4P members will add resources to it. The ultimate goal is to have a system where, as I said, we can navigate from people to data to projects to publications to curricula and other components of EarthCube. We started doing that. So some components are in place, and you may have seen this system called Member Connections. It's also available from connections.earthcube.org site. I will search for Paleo. First of all, you can see that there are not that many people. We would expect more people to register, but also the diversity of primary domains that Paleo people represent. And you can look at places here, but also see what research interests are members of this group. The next step would be to navigate from here to data and to models. We also have inventory of models. Yeah, and I want to add with a pointer to a short questionnaire that we put up on that we have online from the Data Facilities Workshop, where we try to ask what would be potential added value of a cross-domain resource like CINERGI, given that domain information systems do a lot of this work already. And we had quite a number of interesting results. So you are also very welcome to answer that survey. For example, making metadata from facility available to search using standard metadata has been very important for people. Everybody answered very essential to function of identifying issues related to data and metadata quality and completeness and reporting this information back to the facilities. And generally, it appears that there is a need for centralized search and centralized issue tracking and links open data type interface for EarthCube that would connect data with other types of resources. Finally, this is the development team. Yeah, it is the last slide.
Perfect.
Yeah, so that's the development team from several organizations, from SDSC, Lamont, Arizona, University of Chicago, and OBC. And we have several community partners and look forward to working with RCN project like yours. And also we have been working together with a few building blocks things because CINERGI seems to underlie a lot of work that other projects are from. I'll stop here and take questions.
Great, thank you very much, Ilya. That was fascinating. And questions coming in, again, because people are muted here, best way to send in questions is through the chat window to Leslie Stu, and she'll report out questions to Ilya.
Okay, great. We do have one first question that asks, okay, how do I add myself to the member connection site?
You need to register at the EarthCube website, and then we'll harvest your information and put you in. After that, once your card is created here, then you just double click it and edit your information.
Okay, thanks. We'll be sure to keep a record of these questions so that there'll be a written answer to them as well.
Mm-hmm.
Okay, here's the second question. How will CINERGI be maintained and kept current because the state of these resources are changing quickly?
Right. So the big part of it is harvesting mechanism, and several systems like GeoPortal, for example, have a scheduled harvesting. Within MongoDB, we're also working on scheduled harvesting that will let us revisit the resource from time to time and reharvest what it has. But that certainly does not guarantee us from having stale systems. So at some point, we only do initial level of search, and at some point end the search to the main systems where you would be able to get up-to-date results.
Okay, so next question. Is there a process or plan CINERGI will use to test resources to ensure that web links and connections are still fresh?
Yes. So as we set up harvesting, we will essentially the harvesting routines will go to these resources, and we will have a report. We will have two types of reports. One is whether these resources are still alive and they return harvesting results. Then the harvested data are placed into, let me get back to that picture, to this one. Harvested data are placed into staging database without validation, and then we have we'll have validation tools. We're working with that on that with OGC group that have developed such validation for OGC type resources, but that same team engine can be used to validate metadata completeness and consistency in given spec and services as well. So based on that validation, we will see which parsers need to be invoked to complete, to improve the metadata, and also generate report that will go back to the source that we harvested.
Okay, thanks. We have a lot of good questions here. So the next one is there a way to add other domains to the member profiles in the member connection system? And is there a way to link people to projects?
The second one, the answer is not yet, but it's on our plate. The first question is very simple to do. Let me just show you how to do that. I'm sorry, I don't know keeping on, but So when you edit the profile, you just click Other, specify a new domain, and then it will automatically be added to the tasks.
Okay, Jack, how are we doing on time for questions?
I think we have time for one more question.
Okay, so if your question wasn't read, we will ask Ilya to answer it offline, and we'll put the report of it up by the webinar page on the C4P EarthCube site. So the last question is, will harvesters support hitting public APIs offered by resources?
If I understood your question correctly, so you're talking about resources that publish harvesting APIs, right? Or some service APIs that lets us get to the metadata.
Yes.
Right. Definitely we will use that. Definitely. The problem is when there's no such API, and then we'll need to talk and see how we can get the metadata. The bigger issue is that metadata may come in many different profiles and may be incomplete, and that's where the bigger issues are.
Okay.
Okay.
Thank you again very much, Ilya. That was really interesting. And again, as Leslie mentioned, if you have questions, some questions were sent in that we didn't have time to answer, since we're keeping ourselves to a strict 60-minute format for these webinars. But we'll apply to those offline and post those up with the archive of these webinars. So Thanks very much. And now we have Dr. Eric Grimm of the Illinois State Museum. Dr. Grimm will be talking about the Neotoma Paleoecology Database. And you may start when ready.
Okay. Hello, everyone from snowy Illinois. I am hoping that our internet connection stays because we're in the middle of a raging blizzard. My name is Eric Grimm, and I'm going to talk to you today about the Neotoma Paleoecology Database, which is a database that is assembling a number of other databases or merging a number of other databases. I am a Director of Sciences at the Illinois State Museum, but importantly for this, I'm a PI of the Neotoma Paleoecology Database project. This project is funded by NSF Geoinformatics. There's 10 principal investigators from 9 institutions, and there's about 20 collaborators, most of whom are international. What I'm going to do today is give an introduction to Neotoma, a tour of the website, an introduction to the Neotoma API application programming interface, and to the steward tools for data upload or update. Okay, what is Neotoma? It's an open access multi-proxy community database for the Quaternary and the Pliocene. And it looks like we're starting to dip into the Miocene as well. One of the most common questions we get, first question we get is, where did the name Neotoma come from? It's named for the pack rat, Neotoma, which is a multi-proxy data collector. We had a workshop at the beginning of this project, and probably the biggest argument was what to call the database. This was started in jest and it ended up as the name. But there are multi-proxy data collectors. This is Paul Martin with a pack rat midden. These guys collect bones, they collect plant macrofossils, and they collect pollen in their middens, so they are true multi-proxy data collectors. So, Neotoma. What are the purposes of Neotoma? We have many. I'm going to discuss just a few. There are scientific purposes. One very important one is to enable joint analyses of multi-proxy data sets to address paleoenvironmental questions that transcend those possible single proxy data sets. Now, many of us work with, for example, pollen. We work with maybe Pleistocene mammals. But to try to look at mammals and vegetation together has been quite difficult because the data reside in different data sets, different structures, with no way to simultaneously query these databases. And so Neotoma is addressing this issue. Another, which has been very important for funding in the past, is to provide data for climate model validation. Particularly pollen data have been very valuable for this. We have a number of practical objectives. One is simply to provide a safe long-term archive for a wide variety of paleo data with a common structure. And the other is to lower the overall cost of paleo data management by having a common structure for many different kinds of data. Some of the design concepts of Neotoma are, it's a partnership between domain scientists and information technology specialists, where the science is driving the IT. It offers a database infrastructure to specialists in various taxonomic groups who will not necessarily need to develop or even necessarily understand the core information technology, but who can learn to input, update, and extract data through hopefully a user-friendly interface and have control over disciplinary taxonomic issues. Neotoma can accommodate virtually any kind of fossil data, and not only fossil data, but chemical data, isotopic data, geological data, all sorts of data. It's a centralized database with virtual constituent databases, for example, a North American pollen database and FaunMap. These two particular databases have been around since the early 1990s. It's incorporating a number of them here in this list and some more besides that. Most of these are already in existence. However, the last one there, the Alaskan Archaeopaunas, is one that's come into existence recently because it could utilize the Neotoma structure for its own use. The constituent database cooperatives may develop individualized websites to front-end the database if they would like to. And there's a capability for data stewards to remotely input and update data, and that's a very important feature. And finally, access to the data by anybody with internet connection. The database is physically located at the Center for Environmental Informatics at Penn State University. However, as I mentioned, anybody can access it wherever they are, and stewards to upload data from wherever they are, manage data. It's a large database with many tables, and this is actually it's an entity relationship diagram. Doesn't show a complete data set, gives you an idea. It's deployed in Microsoft SQL Server. There's a manual available that explains, it describes every table and every field in the table, so you can learn about it and examples of queries. This is downloadable from the website. We're asked to address challenges, and I think some of the major challenges that we have are, first of all, the ingest of new and legacy data. We have a database structure that will accommodate these, and we've been ingesting data, as I mentioned, in some of these databases since the 1990s, continuing to do so. And this includes ingest of individual data sets, of course, newly published data sets, but also legacy data sets. These data, the complete data, are often not published. For example, pollen, diatom, ostracod data are usually not published. Occasionally, they may occur in supplementary tables, but usually you have to get the data from the author. Critical metadata we find are often missing. Things like I've entered many sites, and it's almost unbelievable how often latitudes and longitudes are given, for example, or how often lab numbers for radiocarbon dates. So we have to. It's a challenge. The other is the merging of existing databases into Neotoma, which is too big of a subject for this webinar, but it's one of the challenges, but it's something that we do. A big problem is age models, and many of the age models are in radiocarbon years only, especially the ones that were ingested in the 1990s. For age models that are in calibrated years, one problem is that the radiocarbon calibration curve is updated periodically. For example, there's the InCal 2004, 2009, and recently the 2013 curves, and ones before that. And of course, whenever the calibration curve is updated, potentially existing age models using old calibration curves are now obsolete. All the necessary metadata for replicating age models are not in the database and often not published. For example, they may say they fit a polynomial, but not tell you what the order of the polynomial was. Some of the new Bayesian methods, they may tell you that they used Bacon, for example, a Bayesian program, but they don't tell you what the priors were. And finally, there's no statistically robust estimates, for the most part anyway, for ages of analysis units or for interpolated stratigraphic ages. The good news is we just had a workshop in Belfast, Ireland, Northern Ireland, sponsored by Neotoma, NSF, and Pages, called Age Models, Chronologies, Database Workshop, and we addressed many of these questions. I think made some good progress on addressing these. Okay, that is my PowerPoint, and what I want to do now is look at the website. This is the Neotoma website, www.neotomadb.org. At the top of it. Okay, there's lots of things here, and we don't have time to tour it all. What I want to do is look at a couple of useful tools. One tool probably most often used is called the Neotoma Explorer. This is a tool whereby you can look for data with a mapped interface. And just for example, I live in Illinois, so I will type Illinois. Do a search for everything in Illinois. Okay, it told me I found 265 sites in Illinois. Here they are. So here's a map of the sites. If I place my mouse over one of them, give me a little bit of information. Okay, Chatsworth Bog. I click on it. There we go. I click on it. It comes over here in the tray. It's Chatsworth Bog. I click on that. It tells me there's a pollen data set and a geochronologic data set. I click on the data set. This will be the pollen data set. Well, it should come up in this spreadsheet here. There it is. Okay, the pollen data set came up in the spreadsheet, and you can either copy this So here's the data. This is all the following data back to home. We're running a little bit slow here. Okay. Here's the pollen. You could copy this to the clipboard and paste it into Excel, or you could download it as a CSV file. This is stratigraphic data. You can look at it, and there's a pollen diagram of the data. The pollen diagram is very useful for perusing the data. You click on site, you get some information about the site, the latitude and longitude, and importantly, the publication. And then the chronology. This is the age depth diagram. So this is a nice way of perusing the data set. Let's go back to the search. I'll click on another one here called Mode Rock Shelter. Okay, this one has a vertebrate fauna data set, a geochronological one. Click on that. Samples. And that came up quickly. Okay, so here's the geochronologic data set, and you see many fauna here and many analysis units. And again, you can download this, copy this, paste it to Excel, or download it. Okay. Let's see. And finally, you can search for taxa names if you want to. So I'm going to do Smilodon. This is the saber-toothed cat. Search for that. And this shows me all the sites that have Smilodon in the database. And of course, you could click on one of these and get some more information. Here's Reason Cave, for example, and there's a data set for it. And Smilodon is one of the taxa included in this data set, but it's a very large data set. Okay, another useful tool, let's go back to the website, is under Tools here, and it's called Taxamapper. And by the way, Taxamapper is going to be merged with Explorer probably in the next month or so, I understand. So this will actually be a unified tool. This is a tool that's very useful for perusing the database for research purposes, but also for education. And what I'm going to do here, I'm going to look at spruce. So I'm going to, from 18,000 years ago, 12,000 years ago, click this, Advanced Taxa Selection. I'm going to type Picea for spruce. Go. I'm going to select all of the spruce taxa, save. And I'm going to say they have to be at least 50%. So at least 50% of the pollen have to be spruce. And add that. Okay, these are all the sites that have spruce between 18,000 and 12,000 years ago, at least 50%. So this is the late glacial spruce forest south of the ice sheet. The ice sheet will be in here. Okay, now I'm going to add another taxon. I'm going to add a mammal. I'm going to add mammoth, mastodon. It brought up the mammoths as well, so I'll add just the mammoths here. Save that. Add that. Okay, mammoths are in the green dots, and it shows you that mastodons lived in spruce forest, which many people believe, but it also shows they were living down here in Florida as well, so they certainly weren't up in the spruce forest. I find this very useful. And then there's just one other thing. We'll just add a single taxon here. I'm going to add Mammuthus. I'm going to wait, come up here a second. Mammuthus columbi, the Columbian mammoth. There. So now we can see that the Columbian mammoths have a distribution that was quite different from the mastodons during this late glacial period. So I think you can see this is quite a useful tool. Okay. I want to switch now to let's see. I'm switching now to the Neotoma API. Now, if you want to use the database besides what's available right through the website, you can download the entire database, but we're thinking that that is probably not the way people do the future, and it's not what we're recommending, but that instead you use the API, the Application Programming Interface. These are web services that can acquire data. I think I'll just give an example here. So here's sites, there's a URL. I can pick one here. So here's an example of response. This is what they look like structured in JavaScript object application. I click on one here, sites here. Okay, that's site number 526. Or if I go back, if I pick all the sites here, this is all the sites that have the name lake in it. You see, it's just a URL up here. I can type in a particular lake, a site of mine, and that gave me the information of the lake. Now, JSON is text. It can be used in a number of programming languages, but another way, there are other ways to utilize this, and there's some examples here. Well, that's taking its time, so I'm going to switch one I've already opened. What I'm going to talk about now, this is another interface to use the API is through R. R is a popular package for statistical analysis, mapping, has all kinds of uses. Simon Goring at the University of Wisconsin has developed an R package that accesses the Neotoma data. And just some examples here. Here, this is for installing, and then here's the R code right here to plot a map of all the sites with mammoths in the database. And here's one that just plots the dates of all the publications. So maybe kind of interesting, but this is useful. It just gives some examples. I think this R package will be another way that people can utilize the database. The web services can be used, standalone programs, websites, you name it. Okay, this came back here, I think, finally. Okay, this is another example here, back here. This is using the API, a Google map. This is showing a map that would show species, for example, Smilodon. Find the Smilodon, map them, and they'll come up here in a moment. They should come up in a moment. There they are. These are all the sites with Smilodon. It's what we saw before. And the code for this, we just view the page source. Here's the HTML code for that. It's really not that much. And so this could be modified to put a map on your own website if you wanted to. Okay, the final thing I want to talk about now is the ingest of data, or sorry, the upload of data. We do this through a program called Ilya, which I wrote. And the problem is that this is a complicated database with a lot of data, a lot of metadata, and we need to ensure completeness and accuracy of the data and metadata. And that needs to be done with a program interface. So here's some examples here. This is actually a site that was uploaded recently.
Eric, 3 minutes.
And okay, that's fine. And this is showing this is Little Dollar Lake. It's a spreadsheet of data. The data are entered here. There's metadata. There's metadata tabs, for example, site. And we try to do as many things as we can to pull down menus so you don't have problems with mistyping names and so on. It does lots of checking so that north latitudes are actually north and south latitudes and so on. Information about the collection units, that would be the cores, about the data set itself. Publications, this is from a thesis. Contact people here, and I'm the one who uploaded it, so I'm there as well. And geochronology, this is one that has one radiocarbon date, and age models, this one has 2 age models, one in radiocarbon years, one in calibrated radiocarbon years, and here are the age depth points that were used for that age model, one radiocarbon date, 2 stratigraphic dates, or 3 actually counting this one, plus the top of the core. And this is where all this data is stored here. Another example here, this is another one we've uploaded recently called Round World Lake. And there's a number of things you can do before uploading if you want to. For example, you can validate the spreadsheet taxa. So this is going out to Neotoma. It's looking at all the taxa in this spreadsheet. It's going to see if they're in the database or not. Okay, it found that 2 were not, but it says Neotoma has a valid name for them instead. A synonym, in other words. You can click the rat here. It'll tell you why that is if you want to know. So it says this one here is 44 North America 2006. If you decide to accept those, then you can save the original ID if you want to. Click, that will save the original ID that the author called it. replace them, and that will replace them. Okay, and finally, look at one more. This is a faunal data set. It consists of only one taxon here, Arctodus simus, and let's see. I'll look at some more things here. Okay, this one had a right ulna. It's this is the units. It's redeposited, and there's one there, and this is the age or age limits for it right here, and all of that comes out of these other tabs here. Okay, how are we doing for time, Jack?
We're about done here. If you could wrap up next slide or two.
I can wrap up now. That's fine.
Okay.
Okay.
Great. Well, thank you very much, Eric. That was great. And so now we can open up for questions. So again, if you have questions, please keep your mics muted and use the chat window instead. And Leslie, if you can send questions to Leslie, she'll read them out for Eric to respond to.
Great. Okay. The first question is, what are the current spatial and temporal data ranges and density in Neotoma?
Okay. Since you asked. I actually saved this one here before it came on. This shows a map of all the sites in the database right now. So that shows you the spatial distribution. North America covered very, very heavily, as you can see. In fact, all those blue bubbles are covering up all the red bubbles that are there. Pollen data from Europe, across Eurasia, and there are some other projects now coming online for faunal data and other data from South America as well. Also African pollen data that will be ingested in discussions with other groups. This is the current status right here. Was that the entire question?
I get also temporal.
Oh, temporal. Okay. Well, the database was originally intended for the last 5 million years, the Quaternary and the Pliocene, and the lion's share of that data would be Quaternary and the last 20,000 years. But there are data that go back to the Pliocene, and a lot more Pliocene data are coming in now. And as I mentioned, it looks like we'll probably be extending into the Miocene as well.
Okay, the line is open. Another question is, how many people do you have entering data into this database?
We're at this point right now, it's a small number because the software for uploading we're testing it right now, and so the answer to that right now would be 3, but we think that's going to expand pretty quickly. So we uploaded the first data set remotely in December, and now we're testing it with different data sets and different parameters, but I think that's going to expand pretty quickly.
Okay, so another question, if I want to add data to Neotoma, how can I sign up?
It depends on the kind of data. There's a place on the website where you can do it, or contact one of the data cooperatives. Neotoma is a consortium of data cooperatives. So, for example, there's a North American pollen database that it doesn't exist as a separate database anymore. It's part of Neotoma, but it still exists as a cooperative. And the FaunMap database, for example, is uploading faunal data from Quaternary faunal data from North America. But if there are, and there's the European pollen database, Latin American pollen database, these would be some others, and the Ostracod database, Nanode is another, a number of them. So that's normally you would probably submit it to one of those groups, although it can be done through the website. And I think we're going to improve the way that can be done actually. Also, if there are data groups out there that have another kind of data that aren't in Neotoma and would like to be able to upload data themselves, I mean, that's something certainly that we can accommodate and we encourage. And also, it doesn't mean that that data have to come through the North American pollen database, for example. I mean, if somebody wants to be able to upload data from a particular region and appoint somebody to be a steward, and the steward requires some training to do it, but we're encouraging that. We want that to happen. And like I mentioned, there's this Alaskan Archaeofaunus database, which is now uploading faunal data from Alaska.
Okay, the next question is, are there taxonomic groups missing that need to be entered?
Yes. Chironomids, there's nobody working with chironomids right now. It would be nice if there was, if a group would. I mean, basically, the chironomid people need to organize themselves to do it, I think. Most of these ones are people who have not had a database in the past. That would be an example. Testate amoebae, there is a group that is working on that. Let's see. Another one that is insects. Insect data are being uploaded, primarily coleopterans.
Okay, next question. Can you show time slice movies?
We hope so. There were time slice movies that were shown. An application that actually came through Jack Williams that accessed the old database, and we had discussions about that accessing this database. So I think that's something that's on our agenda for development.
Next question. How difficult is it to modify the Neotoma structure to accommodate new kinds of data from new affiliated databases?
It's generally pretty easy. It's a fairly normalized database. We've just gone through that, in fact, outcome of this workshop in Belfast. I mean, we knew this was the case. We have geochronologic dates like luminescence dates and cosmogenic dates where we knew we weren't capturing all of the metadata necessary to go with those dates, and just made some modifications. Typically, that involves either adding new tables or sometimes fields to tables. But in general, it's not difficult.
Okay, that's the last question right now. So I guess we have a minute or two back. Is that true?
Yeah, time-wise, we're a few minutes ahead of our hour closure, but that's okay. I'll talk slowly for a sec here. Then if any questions come in, then great. Otherwise, we will wrap up and say thanks all to attending. Thanks especially to Eric and to Ilya for leading off here and taking the first round of these webinars. I think this went very well, and it was really interesting to see both presentations. So we will have our next webinar 2 weeks from today. We'll be running this on this every other week format. So if I'm doing my calendar right, that should be the 18th of February will be our next one. And hope to see you all then. Thanks again, and see you on the 18th.